Today's webcast is on better sheet production tools in Civil 3D. My name is Brian Lewandowski. I'm the product manager here at CTC Software, and I'm going to give the presentation today. Now, what I mean by better sheet production tools in Civil 3D is how can we do this more effectively, more quickly, more dynamically, because we all know that creating sheets can be a very time-consuming process, especially when projects change. So I'm going to walk you through a couple of the robust tool sets from the SIM project suite, which are daily production tools from CTC Software. Then I'm going to show you in Civil 3D how we'll use these in an example. So first one is about plan and profile sheets, and I'm taking plan and profile, but it could be plan and plan, profile, profile, plan only, but basically a series of sheets that are, tracing along an alignment, something like what I've got on the screen there. And so we've got a tool called Sheet Generator, and what it does is it takes the view frame tool set and completely recreates it. Now, why did we do that? The native tool set does one thing, it creates your sheets, but what it doesn't do is allow you to update your sheets. So Sheet Generator not only creates plan and profile sheets for you, but it will update your sheets after changes to your project, right? So if there's a shift in the alignment, something like that, any kind of change, that can have a trickle effect through your entire sheet set. I'll show you how Sheet Generator will do that. Sheet Generator incorporates profile views, sheet set fields, match lines, everything you might put into your sheets. Sheet Generator handles with the big addition of being able to update those sheets after the fact. Because what would you normally do? You would either delete all those sheets and then create them again from your view frames, or you go and manually update those viewports and deview twists and all that kind of stuff. It becomes a very time-consuming process. Next thing I want to look at are tables or legends, be they in our sheets or on kind of an overall legends sheet in our project. Whatever it is, generating these things can be fairly time-consuming. Again, they're fairly manual. If it's a legend, a lot of people have a one-size-fits-all. They drop in and then they kind of edit things based on what's in their project. Or they just leave the one-size-fits-all legend or table, and it's showing things that aren't necessarily in the project, not necessarily what we're after. Okay, so Data Wizard is another robust tool we have in the SIM project suite. Allows us to scan any number of drawings for any number of AutoCAD or Civil 3D projects, and we can generate legends and tables and all these kinds of things. Now, some of you might be thinking, well, Brian, there's tabulation tools in there. I can do some of this stuff, but can you do all AutoCAD objects, all Civil 3D objects, and can you do it all in one table, all in one place? And more importantly, if it's legends, can you generate graphics like this? So that's what we're after with Data Wizard, is to create this stuff automatically based on just what's in the project. It can be limited to layouts, viewports, you name it. And of course, these things can update if drawings change. You simply refresh your table, and then changes to those objects will be reflected. And you can save out templates for all these different types of tables and legends you create. You can save out templates to quickly recreate those on other projects or other sheets, what have you. So lots of power there. I'm going to jump into Civil 3D and show you how some of this works. So what we're going to do today is we're going to generate a set of plan and profile sheets. Then I'm going to go through and make a, what might be a common change to our project, a shift in alignment, and we'll see that how that would screw up all of our sheets. And then we'll go ahead and use Sheet Generator to automatically update all those sheets. And then we're going to jump into Data Wizard, and we're going to generate some legends based on our project, legends or tables, whatever you want to call them, based on the data we have in here. And so what I'm starting with here is a sheet where I've got data referenced in and X referenced in, information from base files. In this case, here's my base file with alignments and a pipe network, and then a variety of just AutoCAD polylines and blocks and things like that. A real work of art, right? And so here's our sheet file, or basically our working template for a sheet file. And this is how Sheet Generator works. You bring together the data you want, and then we automatically create all the sheets for you. So at this, I'm going to run Plan View Shapes. And it's a fairly intuitive interface. I select my alignment. I select my starting stationing. Okay, I can snap in the drawing here. I can also just type in here if we wanted to go from station 50 plus 50. Then I can snap to the end, of course, as well, or however far the distance is that I'm generating my sheets. I've got a viewport scale that's going to read from the native, or excuse me, the current model space scale. And I've got some layer options around print area blocks. And so what print area blocks are is basically the representation on your sheet that we're going to place these viewports. And I'll show you those in just a moment. Next thing is the match lines. This is a common way we think in terms of our sheet layout. What kind of distance do I have between my match lines? Okay, it depends on your sheet size, depends on the scale of your drawing. So we're taking that 20 scale that was specified here, and we're calculating that, look, based on the print area on your sheet, you can fit up to 500 feet. Well, I want a little overlap, so I'm going to say 400 feet. I can round my match lines to land on the nearest plus 25. And then here's a feature we've created beyond the native tool set, which is to avoid alignment vertices. This can be really key if we're trying to avoid landing a match line, say, on a PT or a PC or any kind of vertice in our alignment. It'll avoid that based on a buffer. And so you can change that buffer. So now we've got it set to anything within 10 feet, move my match line to the next plus 25, such that I still stay within my distance between match lines. So it would shorten it perhaps to, say, 375 if it needed to avoid a PC or a PT or a PI. We've got some enhancements coming on that where we're going to be able to avoid things like pipe network structures or blocks or anything you specify that you may not want to land a match line on. And moving on, we've got control over the masking or the clipping beyond our match line. Now, do you want it to mask past the match line, or do you want it to show information past the match line? That's what this option is here. And a few more layering options. And I'm going to hit Finish here, and you're going to see everything lay out along our alignment. Okay. Now, we talked about those print area blocks. What are those? That is these red objects right here, and these are nothing more than AutoCAD blocks. And so what Sheet Generator does, it'll take my sheet template like I have here, and all that we ask from the tool is that you put a rectangular block that represents where your viewport should be placed. And then we use that and the drawing scale you specify, and then we can lay out our sheets in model space like this. So very similar to the view frames in that way, but a lot more flexible in that these are just simply blocks. The red rectangles are blocks. These cyan lines are polylines. We call these view shapes, but they're nothing more than a polyline, and they're going to represent my viewport when I create my sheets and when I update my sheets. Okay? So because these are just simple objects, I can move these around any way I see fit, tweak them. Okay? If you don't like the way the automated layout is happening, we can play with that in a manual way. Okay? It drops these yellow lines in here, which are just guides for where the match lines will be. But you can see my cyan lines are where, or they're clipping rather, at the match line. Okay, so let's move on. Let's create our profile views. This one, in fact, we just use the native tool set to generate profile views. And then acknowledging that, with the native tool set, one of the big limitations are it's difficult to control your profile view heights and stations. Oftentimes that's a complaint, is that the elevation range doesn't come in the way you want, or just the way the profile views in general come into sheets. It's not necessarily preferable with the native tool set. So we address a lot of that through a couple other tools here. One here is a networks to views command. I can choose any number of profile views. I can select them like that. And this is going to add pipe networks, any number of pipe networks to my profile views. And you might be asking, why do I want to do this? Couldn't I do that when I created the profile views? Well, the point is that we want to add only pipes and structures that fall within the station and elevation ranges of our profile views. Makes a big difference with drawing performance. So we're going to say, look 50 feet to the left and right of my alignment and find any pipe networks that are there and add them to the profile views. So if I zoom in here, you see them show up. Okay. And some of you may get this, the fact that it's adding only the pipes and structures that are within that view, again, make a difference with your drawing performance. If I would have added those when I created all the profile views, I get the entire pipe network in every profile view. And there's a number of other kind of oddities and annoyances that come with that. So that's adding the pipe networks. You can, of course, do that outside of using this entire workflow. You could use it after the fact. If you've generated profile views, normally you have to go pick those pipes and structures in model space and then say, draw parts in profile view. Well, with this, you can just say, pick all these profile views, add all my pipe networks, and you're done. So the next module is the Adjust Profiles. This is a tool where it gives us really detailed control on the appearance, the height, and the station range of our profile views. And it's one of the things with this tool set that give you a lot of extra features beyond the native tool set. So right at the top here, match plan view stations. Okay, in a plan and profile sheet scenario, of course, that's what we want. So I'm going to auto match to the view shapes on that layer. Okay, and that's the cyan lines over here in model space. And here's a nice extra feature. I can add a station buffer to my profile view. Okay, so I can add, in this case, let's say 25 feet, or whatever your grid spacing might be, an extra 25 feet to each profile view on either sides. Seems like a no-brainer, but there's no way to do that except manually outside of this tool set. So we can do that if you want some of that overlap. And then the profile view heights themselves. Right off the bat, I can choose to round the elevation ranges to land on the major elevation tick of the profile view style. Basically, it makes sure your profile views land on whole numbers and not something random like 832.17, right? Land on 830, 835, whatever those major elevation ticks are in your profile view style. And then I can automatically center my profile views on any number of objects, surface profiles, pipe networks, you name it. So those of you who have used the view frames a lot, you know a lot of the limitations on controlling how those profile views come in. Here you have a ton of control over it. I can set an overall profile view height. I can adjust a delta up or down after the fact if perhaps I have some really deep sanitary manholes, and I don't quite want that to, dictate the whole centering or the averaging out of my profile view. And then other options for controlling the profile view heights as well. So I'll hit OK, and what you're going to see here is all of these profile views update at once. So I'll hit OK, and they all change at once. And they did a few things for us. You'll notice the stationing. 58 plus 75. This one starts at 58 plus 25. So it added that 25-foot overlap. And it also looked at the data within each profile view and centered it on just that data we chose. Okay, now if we had done that and some pipes or structures that should have been there now don't appear, you simply run networks to views up here again. Choose all my profile views, hit enter through the defaults, and now all those pipes and structures will show up again. So it's a really dynamic tool set. We're trying to build something that you can jump around at different stages in your project, in your workflow, and tweak things, adjust things as you see fit. Okay, the last thing is to place print blocks. Okay, again, print blocks are these just simple rectangular blocks in our sheet template. And I have different sizes. My profile view, I've got this much space, but my plan view, I've got a bigger one, okay? So I'm simply going to place those on my profile view so I know that they fit within my sheets. So I'm going to run this last command, profile view shapes, grab all my profile views, and I'm going to line these with plan match line. Again, what this means is that the starting stationing of my profile view right here is going to line up with my plan view. So we want to do that, okay? And then we're also going to look at a feature here, which is to place a masking block over the buffer area. So if you remember, we added that plus 25. This is a common thing people want to do, which is to have some extra grid spacing beyond or in their profile view, but not show any data. So we can do that in here. It's an option. You don't have to do it, but it's a feature. So if I hit finish, you'll see now it masks in that extra 25-foot buffer. Okay, so just another feature there. I know a lot of you guys do sheets in a lot of different ways. Some clients dictate it one way, others another way. Okay, Sheet Generator can handle all that stuff. And all we're doing actually here is dropping a masking block in here with a wipeout in it. Nothing extravagant, just a block that matches our standards or your standards. I've got one set up here, but in the tool set, by the way, it comes with some of these blocks that I'm using. So there's that masking block. There's those print blocks on my sheet template. Okay. Then what we're also going to use is a block with attributes in it for our match lines. So some of you might be thinking about the native tool set with the match lines. They're really kind of finicky, buggy things. Okay, we bypass those altogether and we handle things in a very universal way using attributed blocks. Okay, now I'm about to create my sheets, but I want to point out one thing, which is we have basically our sheet appearances created already. I see what my sheets are going to look like. Not the borders and everything, but I see what it's going to look like in plan view. I see what it's going to look like in profile view. And I can sit here and work with this all I want. I can adjust things, tweak things in this state before I create my sheets. Or what I'll show you is, even if I have created my sheets, I can come back here, adjust things in model space, and then push those changes to my sheets. So let's move on and let's create our sheets themselves. So we go up here to the Create Layouts command. Prompts me to save my drawing. I'm going to say yes to that. Then I get some common options here. What kind of sheet configuration? I've got plan and profile. So we'll stick with that, but you can see I've got all the other options there. It's defaulting to some layering and alignment options that I had chosen in previous modules. Now here it's giving me a list of all the sheets I'm about to create. Now perhaps I didn't want to do them right off the bat. I could select just some of these or all of them. Either way, you have control on it. We account for north arrows, so it's going to automatically rotate our north arrow. We're going to insert match lines, okay, and we're going to auto-populate things like stationing, the sheet number, all these kinds of things, the information you would want in your match lines. We handle all of that. And then we can even insert match lines in our profile views. There's no way to do this natively. I mean, you can do it manually, but no way to automate it like this. That feature is in here as well. If you don't want it, you just uncheck this, but if you want it, you turn it on. And again, we could have it centered on objects in the profile views, or we could have it just centered on the view itself. I'm going to let it center on the view. I hit next. Final screen is what layout template am I going to duplicate? How many layouts per drawing? Okay, so this is going to create new drawings for us. New drawings where I have those data references and those X references that are already set up in my working drawing here. It's going to generate new sheet drawings for us. I've got control on the naming of the layout tabs themselves. It's going to be start to end station. And then the layout storage itself, what are the new drawings? What are those going to be named? Okay. And then what sheet set file am I going to place all these sheets into? Okay, that's important that we tie in sheet set manager as well. And we do that here. So I'm going to hit finish, and what you're going to see in the background is the creation of our sheets. And then we're going to highlight and show you the real cool part of this module, which is the update layouts, right, where we've got changes that happen to the project, and then we can push that to all the sheets. So I'm going to hit finish here. You're going to see pretty quickly in the background these layouts being created. It's making 10 layouts for us here based on our chosen template. It's going to drop all those viewports in there. It's going to rotate them. Basically what the native tools do, which is cool, right? The native tools do a great job at creating things. What they don't do is allow us to update. So let's take a look at a couple of those sheets here. Notice they come right over here in Sheet Set Manager. I'm going to double click this to open up the new sheet drawing. And you notice all these layouts. I said 10 layouts per drawing, so they all came into this drawing. Okay, I can click through here. And what we've got is our match lines. And that's, you can edit this block to look however you want, but notice it's giving me the stationing, it's giving me the sheet number of the adjacent sheet. Okay. The way we handle the masking beyond the match line here is to just trim the viewport itself at the match line, as opposed to using that kind of that Civil 3D match line object that kind of does some voodoo to mask that area. Okay. And then down here in Profile View, I told it to do Profile View match lines. Okay, there's that extra grid spacing we said we wanted. Okay. Some of you might be thinking, well, I want my grid to go, you know, an additional 25 feet, or I want my lettering on the, or my numbering on the inside of the grid. Okay, whatever you want to do, you can do it. You edit your profile view styles to look however you want. And then you adjust these blocks that you create for your sheet template, make those whatever size you want, and you can place your profile views however you want within them. And it'll be automated all with this tool. Okay, these match lines, if we look at those again, these are, if I double click on them, these are, like I said, attributed blocks, and these are fields coming from Sheet Set Manager itself. Now, if we go back to model space, let's look at a change, right? So let's come to our base file. The base file here is this design base over here. It's shown you earlier, it's got alignments in it, some blocks, a variety of things, a pipe network. Likely you would have, you know, 2 or 3 base files, but same kind of situation. If there's a change to something, and let's just go ahead and do that now. I don't even want to do a big change because it's the smallest of things that can wreak havoc on your sheets, right? You might think, oh, whatever, alignment shift, not a big deal. A slight change in, you know, a radius of a curve. Okay, that kind of stuff can screw up your entire set of sheets. So I'm going to save this base file here, and then we're going to go back to our sheet file, and we're going to see after we, you know, reload the XREF and synchronize the data shortcuts, we'll see how everything is off. So I'm going to come down here to the bubbles, reload the XREF, and then synchronize the data shortcuts. And you just saw that alignment shift up here. Okay, that alignment now extends more there. More importantly, look at our match lines. Okay, here's our match line. It's no longer on the plus 25. Everything is off, right? So all of these viewports are off. If we look at one of these sheets, this is saying station 66 plus 50. That's not 66 plus 50. That's 67 and some change. Okay, so everything is shifted, right? And what would you normally do here? You'd go and delete all your sheets and recreate them with your view frames, or you'd manually update this stuff. Either way, a tedious and error-prone process. So how do we handle this? Let's move that out of the way. We simply use the tools that I had used for creation. Okay, those exact same tools are updating or editing tools as well. So let's come here, let's run plan view shapes again. That's where we laid out our sheets in plan view. And let's refresh our layouts here. So perhaps I don't want to go from 50 plus 50 now. Let's say we want to go from 51 plus 0. That's going to make a shift in everything. And then we'll snap to the end of our alignment here, or wherever you would go to in your project. Okay. We're going to keep the same drawing scale, and it's going to remember all the settings you specified before. So it gets this updating of your layouts is really handy because it remembers all these settings in those drawings, and you simply run through them quickly. Now I'm going to take more time here because I'm trying to explain how it works, but in practice it's really quick. You just run through it, hit next and finish, and you're on your way. Here's all those same settings, the match line distance, round the station, avoid alignment vertices. Okay, I'm going to hit finish, and you're going to see a shift of some of these plan view shapes here. So hitting finish, and everything shifted. It was only maybe 10 feet or so to land on that next station. But the way it wanted to lay out now, see, this is 63 plus 00 to 67 plus 00. So the way that shift took place is now everything's actually off 50 feet. If I were to look over here, you can see here's where my new viewport should be. Here's where my old one is. Okay, so right, everything's all screwed up. Okay, so backing up though, we've got the plan views all set. Now we go to our profile views. I run these same commands, adjust profile views. I can grab all of those views at once. I'm going to keep all those same settings, and when I hit OK, you're going to see all of these shift by that 50 feet, all of these profile views. So I'll hit OK, and everything shifts to match that new station, including the plus 25 that we wanted on each profile view. Simply run this last command, profile view shapes. This is if the profile view is to shift within our sheet itself, the placement of it, so that it lines up with the plan view. Again, all the same settings. We hit finish. We might see a couple of these cyan rectangles shift for us. I'll hit finish. Yeah, it looks like a couple of them might have shifted, right? So again, what that is about, you'll notice that the placement of this profile view is further away from the edge of the rectangle than this one is down here. That's where it's going to be placed in the sheet. Well, if we take a look at this, station 74 plus 75, where's that in plan view? Looks like it's this one right here. Okay. This is the plan view that corresponds to that. Okay. A common thing is to have in our sheet the stationing here lined up vertically with the stationing in profile view, meaning where my intersection of match line is here, I want it exactly in line with my match line down here, or with the stationing at least, if I don't do match lines in profile view. Okay, so it's handling those little nuanced preferences for us, aligning our plan and profile views within our sheet itself. Okay, looking at these sheets again, everything is off, right? That's a 70 plus 50, 71. Okay, let's go ahead and update our sheets now. And here's the real bread and butter. This is what we're after, right? Is the ability to update our sheets when project designs change. So I'm going to run the update layouts command. It's going to prompt me to save my drawing if I have any changes. And it's very similar to the crate layouts. I've got plan and profile options. Okay, again, layering and block selection options. If there was any change to the references in my north arrow or my match line blocks, I could do that here. And then here it's going to tell me all the changes. Here's my new station range, 51 plus 00 to 55. And then here's the layout it's finding. You see that down here, 50 plus 50 to 54 plus 50. It's matching up all of those new stations with the old one, and then it's going to update those sheets for us. Now you have control on these. You can override it if it wasn't lining up the way you wanted. And then finally down here, it's going to update all the sheet set fields themselves. So I'm going to hit finish, and again, it's going to go pretty quick in the background here, but we're going to see all these sheets update at once. And I'm doing this, just on a kind of a demo project here with 10 sheets. This works on 5 sheets. It works on 500 sheets. The same difference. Obviously, you've got more drawings you're updating. And there's more processing time there. But we've tested this thing with hundreds of sheets, and it'll update hundreds of sheets in just a matter of a couple minutes. So I'm going to hit finish to this, and we'll see those shifts in the background, the profile views shifting for us, the match lines, the north arrows. Okay. Here's that stationing, and again, 67. Okay, that's landing on station 67. Okay, everything's updating here. Those match lines are aligned here. Okay. If I look at a print preview, we're starting to get something that looks like a reasonable sheet, right? You guys probably have better plots than that, but you get the idea, right? So that's Sheet Generator. Allows us to create plan and profile sheets, plan and plan sheets, you name it, and not only create the sheets, but update them as well. It's a huge time saver, and along the way, again, we give a number of enhancements that give you control over your profile views, the way your plan views lay out. So a real popular tool in the Sim Project Suite, certainly one worth checking out. So the next thing I want to talk about are sheet tables or sheet legends, and how we create those. And right now it's a pretty manual process. What if I want to build a simple legend based on what's in this sheet? Or maybe it's a legend based on all these sheets. Either way, we can automate this with our Data Wizard tool. And so it works like this. I'm going to come up here to Data Wizard. I'm going to run Setup Table. And on this first screen, I've got choices over the drawings I'm going to scan for. Okay, so if we're going to make tables or legends, we need to be able to specify what drawings. Okay, this is going to be a sheet-specific one. Okay, but you'll notice here I can scan my current drawing. I can look for any XREFs. I could even loop in additional drawings. So say I had 30 layouts, and I wanted one master legend for all those layouts, and those were across 3 different drawings. I could bring those other sheet drawings in here if I wanted at the time of creating this legend. But I want to show you the feature where we can limit this to a particular layout. In this case, I'm going to limit it to this one I've got in the background here, which is 67 to station 71. And I can even choose the viewport and limit it to that viewport, meaning only find objects within that viewport on this layout. Okay, I'm going to scan just my XREF, because my XREF is where I have all that base content. This is just my sheet file, but I could look in the current drawing as well. If I hit next, and I'm going to click refresh to this here, and let's check on all of these object types actually. You're going to see this here. I'd mentioned this in the PowerPoint. We've got AutoCAD objects, Civil 3D objects, all of them in here. We can scan for all of them and put them into a single table. This could be QTO, it could be any number of things. In this case, it's sheet tables or legends. In this case, I have a few things I want to tabulate. I've got retaining walls, some trees, I've got a M-liter call out there, some blocks. Okay, so I'm going to grab my blocks, multi-liters, and my polylines. Happens to be just AutoCAD objects in this case here. And it shows me over here the total items I've got. and then filtered items as well. So if I hit next to this, it's going to show me what's appearing, what's going to show up in my legend or my table. It's finding it in that XREF file, and there's an overhead light, a coniferous tree, deciduous tree, a hydrant. Okay, for multi-liters, it's finding this call out right here where I'm calling out my curb lines and the type of curb. Okay, that's an M liter. And then polylines, it's finding that retaining wall option there. Okay, I want to point out a few things. Like if we look at the polylines here, you see filtered items is set to 1. If I go into the filter, what we've done is we've filtered out layers that start with G dash or layer 0 itself. And so let me just undo those ones and so you can see how this works. And get those to show up. I guess we don't have any there. Anyway, I wanted to point out there's filtering here. A lot of times you're going to generate these tables or legends, and things are going to show up that you don't want, and so you can filter those things as you see fit. And the beauty of this is, you can use standard like Windows Explorer type notation, like commas and asterisks, and those kinds of things. Now the information we want in our legend or our table, you simply go to Data Extract. Okay. I've done some previous webcasts where I've showed different use cases for Data Wizard. One was a QTO one. Okay, that's where all this stuff comes into play. 2D length, 3D length, area, volume, northern easting tables, you name it. We can do it all in one place. Okay, but what we're after here is a simple legend or table for our sheet. So I'm going to just pull through the graphic and the layer description, and that's what you're seeing here. We'll go to the final screen. I'm going to grab an Autocad table style called Paperspace Legend. Then up here I've got control on capitalization. Okay, do I want to put a title in there or not? And then I've got scale factors here. I'm going to put a scale factor in there based on my standard. I think I've got everything set here. Here's kind of a preview of what's going to come through. The layer description, the graphic column. And let's go ahead and drop this right here in our sheet. Okay. Now it's a simple table, but it's just what was in our sheet itself. Okay, it's an AutoCAD table. It's just a native object, so nothing proprietary. But you'll notice it's scaling it to the scale of the objects in the sheet itself. Okay, it's grabbing a line sample there. And it's reading this data, this description. I chose layer description, but you could be pulling it from layer name. You could pull it from attributes in the multi-liter block, any number of things. And here, this hydrant, for example, it didn't pull anything through. So I just kind of want to highlight how this works. These are dynamic tables, meaning if something changes in your drawing, they update in the same way. So perhaps you forgot to put the description in that layer that the hydrants are on, right? This happens to be in the base file, but I could just type it right in here and then you'll see what I mean. Okay, so that's the layer description. If I simply come up here now and I run Update Table in Data Wizard, I pick on this, I hit OK, and you see that table refresh and fire hydrant now shows up. Okay, I can run through these other sheets, generate these really quickly. Let's move on. Let's make another one here. And then after that, you'll get the idea. It's kind of the same thing. We've got a change in the layout, so of course that's going to change. I'm going to change that name. And now we don't have fire hydrants showing up because there isn't one in this particular layout. drop that in here, and there's my table or my legend for this one here. Now this stuff gets pretty standardized, right? What you want to show on a given sheet for a given table, a given legend. Now it remembers your settings from the previous time you ran it in that particular drawing. But what you can do is you can come in here and you can save out a template. So this would be like, sheet legend, for example. And I can save out that file, okay? And then if I launch this in another project or in another drawing, I can come right up here to template and browse out to that Data Wizard template for sheet legend, and all the settings will be the same. All the filtering in here, all the data I chose to extract, everything will be saved in that template so that you can execute it really quickly on other projects and in other drawings. Okay. So those are some of the key tools for sheet production in Civil 3D from the Sim Project Suite. I want to wrap things up. If you got any questions about how you get it, it's pretty easy. You go to our website. Many of you guys use this already, and I appreciate you tuning in, just kind of seeing new workflows from our tools. But you can come right to our website, go to the Sim Project Suite. You can get a trial right here, or contact your reseller. It's ATG in the US or Autocad in Canada. So with that, we'll wrap it up. Thanks again for listening, everyone, and you have a good day. Take care.